power called, and what is this 3 called?
This is 20. That equals 27.
No. What is this 3 called, and what is this one called?
All right, this 3. All right, the big 3 is called the base, and this little 3 is the exponent.
Okay, so raised to the power of 3, what is the number called? We are going to, there are specific names when you raise them to power 2 and 3. What are those numbers?
Oh yeah, 2 square number, 3 cubed.
Okay, that is what we are going to do.
This is 3. Yeah, no, that's 3 cubed.
Yeah, so today's class is going to be easy peasy for you, and you're going to finish it really fast because we are going to do only squares today.
Okay? And I mean, we can, if we don't finish this class, then we can just continue it.
Yeah,
next week.
We can see maximum how long you can sit, then we can continue it. So
okay,
you just work out these sums for me. Wait. 1 second. Do you have your notebook with you?
Yeah, I have a notebook.
Yeah, can you please work out these sums for me? Or you can also annotate on the screen. These sums alone. You have to justify your answer. What is the correct answer and why is it false?
All right, so the correct answer is 10 to the 12th power. So 10, all right, so multiplying exponents is all right. This equals 10 to the 12th power. So all right, this is how it works. So
Good job.
So if the exponent is 2, and if you're multiplying by exponent 9 by the same number, then you get 11. And this is not true.
Okay, the second one. What is 2 cubed?
What? 3 cubed 8, 5 squared 2, 25.
Okay, the next one. Why is it true?
Because all numbers that have exponent 0 is equals to 1.
Good job. The next one.
I'll call you when I'm done. Okay. All right. 2 cubed times 3 squared equals that. Let me think this one out. I think this one out.
Why? Why is it?
Because all right, 2 cubed times 3 squared equals 72, and 6 to the 5th power is somewhere in the thousands.
Very good. So the next sum.
Scroll down.
I don't know why I'm not able to scroll down. It is 8935. I want you to write it as a product of an exponent.
I don't know how to do this one.
Do you know how to do expanded form?
I don't know how to like find this.
No.
I don't know. You show me a method. Show me a method of
I'm
how you.
I'm going to ask you to use your brain to find out the method. Do you know how to do expanded forms? Why? Because you have a very big and colorful brain, and it is just sleeping a bit. So I just want you to wake it up.
Okay, my brain is just sleepy a bit since I'm fixated on going to that food jump.
Okay, that you said you had a class yesterday, so that's why we have a class today.
No, I had a class this morning, so I couldn't.
Okay, that's okay. So how do you write this in the expanded form? Expanded form.
Oh,
Write
yeah.
it first in the expanded form.
8,000 plus 900 plus 330 plus 5.
So write that down first, then you can do it as exponents. Can you write it there itself? Okay, wait. Let me just clear so you can. Do you want me to open the whiteboard?
No. So what do I do now to find the GCF or something?
No, this is the expanded form. So now can you express 8,000 to the power in exponent form? How do you express 8,000 in the exponent form? Wait, Gautam, let's just use the whiteboard. Wait, this is getting like too cramped here. Yeah, here. Do you want me to write down the number for you? Yeah. Write it in the exponent form with a plus in between them. First step.
Wait, hold on. I think I can solve this.
Yeah, you can.
Okay, wait. Find the expanded form.
I write the first step that you had written in the slide. Now, how do you express 8,000 in an exponent form? Just 8,000.
Yeah. Oh, so I don't need all this stuff.
Okay.
Okay, so I mean, yeah, that's just 8,000.
8,000. How do you what's
Oh
like?
yeah, 10 cubed times 8.
Yeah,
So that's the answer.
you have to write it fully for all. Remember, Gautam, the number always comes in the first, the exponent form comes second. So put the 8 in the front. 8 into 10 cubed. Not 10. Wait, put the 8 in the front.
Yeah. All right, I know this. This is 10 cubed.
No, wait. I'm clearing it for a minute. Listen. Oh, I cleared mine too. It's okay. Listen. Write it with addition. Okay, that is how. How do you write exponent form? You just don't put it one below the other, right? You put it as 8,000 plus 900 plus 50 plus 3. Similarly, write down the exponent form with an addition sign in between them. Like 8 into 10 cube plus. Good job. Let's go to the next one. It is 4501.
Oh, that's what you mean. Okay, whatever. Oh yeah, that's what you mean by exponent form. Okay. There.
Good job. So you got the hang of it now?
Yeah. Give me more.
I am. We're going to do some bigger numbers.
What's after this problem stuff?
More problem stuff?
What's after all these?
We are going to see in depth about squares. Okay? Squares and square roots.
All right, what?
Square roots. Do you know what is a square root?
Oh yeah, square roots. Yeah.
Yeah, we are just going to cover that. See, you're going to be so fast, we are going to like just breathe.
All right, after this, can we move on to square roots?
This is the last sum. Just one sum.
Mhm.
That's it.
Yeah,
Yep.
I got it.
Hey, where's the number?
No, it's just 10 to the 4th power. It's just.
You need to put a 1 there, baby.
Oh. There.
Good job. Okay, what do you know about the term perfect square or squares? Perfect square.
So, all right, so a perfect square is a number that has a square root. For example, 25 is a perfect square because it has a square root, and its square root is 5.
How do you think they determine this? Whether it's a perfect square or not, in the simplest terms.
Multiply the number same time, and then you get a perfect square.
Can you give me 5 examples of perfect squares?
I wrote 1 so far.
No, you can. Think about your tables. Think about your tables. You'll get all your perfect squares there. Multiplication tables.
Mm-hmm.
Good job. So seeing all this, can you tell me the properties of perfect squares?
What do you mean properties?
Properties are like, seeing all these perfect squares, do you think there are some principles that all the perfect squares have, some rules that all of them follow? All the
No.
perfect squares. Okay, I'm going to help you out with the rules. You're going to help me out with the examples. Okay? Sounds good?
Mm-hmm. So after square roots, it's cube roots, and then
No, we
there.
are just doing square roots. That's it. Yeah. Can you please read and give me an example?
All right, square numbers always end with the digits 0, 1, 4, 5, 6, and 9.
Why do you think they end with these numbers?
I don't know.
Example. Give me an example.
What do you? Oh, okay. So, for example, 25 ends in a 5. 36 ends in a 6.
For 9?
Yeah, I'm thinking. $49.
Good job.
0, 0.
The number of zeros at the end of a square is always even.
Oh yeah, 0, 100.
Is 100 a perfect square?
Yeah, it is.
It is. Can you please work out and show how it's a perfect square?
10 times 10.
Is 10 a perfect square?
No.
So work it out. You can annotate on the screen here to show how 100 is a perfect square.
Hmm.
Good job. I just asked that to pull your leg. 100 is a perfect square. Okay, give me an example of a number that has an odd number of zeros at the end that is not a square number.
Hmm?
So give me
Hmm.
an example of a number. See, 100 has 2 digits, 2 zeros at the end. Okay, so it's a perfect square. Now I want you to give me an example of a number that you think is not a perfect square, which has an odd number of zeros.
1000.
Okay. So an example for number 3, can you read the rule and then give me an example, please?
Or if a number has a 1 or 9 as the last digit, then the square number ends with 1. For example, 11 ends in 1, and 11 times 11 equals 121. That ends in a 1.
Good.
9 is just its digit. 9 times 9 equals 81, and that's 1.
The fourth rule.
All right, 4. 14. All right, 14 ends in 4, and its square root is. Wait, let me do some thinking. Or 196.
Okay.
Or yeah, 6 ends in 16, and 16 times 16 equals 256.
Good job. The fifth rule.
Hmm.
I want
Or
you to use all
the
these
square of
rules.
even numbers is always even, and the square of odd numbers is always odd. 9
Example.
times 9 times 9 equals 81, and odd numbers ends in 1, 3, 5, 7, or 9.
Okay.
All right, 8 times 8 equals 64, and even numbers end in 0, 2, 4, 6, 8.
Good job. The last one.
Square numbers are always positive because two negative signs multiplied by each other result in a positive sign. For example, negative 5 times negative 5 equals 25.
Good job.
Negative times positive equals positive, and negative times negative equals positive.
Negative times negative, negative into positive is?
Negative into positive is negative. Negative into negative is positive.
Positive into negative is?
What?
Positive into negative is?
Negative.
Good job. I'm opening the whiteboard. We finish this, then we are done.
Wait, what is it? What do you mean? What does it mean? What
That
is 22?
That is actually 2 square. I'm sorry for the typo error. It is 2 square. I can write down these.
Can you just put them on the smart board?
Yes, I can. Give me a second. Okay, I think since you're well versed, we can go to the tough sums. What do you say? What's 2 square? You can tell me orally what is 2 square.
4. 2 squared equals 4.
Okay, so we are going to the next sum, which is 21 square minus 18 square.
Okay.
Can you please put across the steps for the sum? No, the working. I don't want you to write it down, just the working. Put the working in steps. Just don't put the answer directly. That's what I meant. Good job.
There.
Okay. What is wait, 1 second.
Is that times?
Yes, it is.
This is just, I think this is.
Okay, wait.
This is one. This is one.
Which is one?
This answer is one.
Are you sure?
I think, yeah, because anything that's divided by the same thing is just one.
Good.
Is it actually one though?
I want you to work it out and then let me know on the board.
Mm-hmm.
You can use the law of exponents for this. The law of exponents that you have to use for this, there's a division that you can see. Division.
Yeah, I know how to.
Okay, the other simple way in which you can do this sum, the answer is correct, but the simple way that you can use this sum. And is 3 square into 2 square 25? What's 3 square?
9.
2 square?
Wait, 9, 4. Oh, 36. 36. This adding those both equals 36. Those both equals 36 times.
What is the simple way using law of exponents that you can do this? You can do it in one.
All right, so when you time, okay, so when you, all right, so when you add, I know the law of exponents. So when the numbers have the same base and when they have different exponents, when you multiply, you add, but when you divide, you subtract it.
So can you please put that method here? That will work out faster.
Yeah, there.
Okay. I asked you for the working, darling, not writing. Okay, it's fine. You got the concept, right?
Mm-hmm.
Okay, what is the answer for this sum? For this. What's the answer for minus 9 squared?
81. Just 81 because like when it's negative 9 times negative 9 and negative times negative equals positive.
Good job. So can you please draw a square root? Do you know the symbol for square root?
Mm-hmm.
This. there should be a thing here. Okay.
Mhm.
First, when nothing is written, it means a square root. If it is a cube root, you write a small 3 here. That shows that it's a cube root.
Okay.
Okay. So how do we find square roots?
Well, let me think.
For the first 10 square roots is very easy. Can you tell
Yeah,
me?
let me name them all.
Yeah.
1, 4, 9, 16, 25, 36, 49, 64, 81, 100.
Okay, and these are called as?
Perfect squares.
Oh, good job. So what do you do for numbers other than perfect squares?
Wait, other than what?
Other than perfect squares.
I don't know how. I mean, I know, yeah, but I don't even know if other numbers that are not perfect squares have a square root.
No, if it is a big number, right? How do you think you can find the perfect square?
Oh yeah, prime factorization.
Repeated subtraction and estimation. Okay, 3 methods.
Yeah, that's what I do sometimes. Like I get square root problems in school sometimes, and when I just know, if I don't know it, then I just try to estimate.
Okay. Estimation for square roots by big number is very easy. Okay, we are going to take the same number for prime factorization and repeated subtraction and see. Okay, and before we go to that, some of the applications in square root are when you're going to learn quadratic equations, algebra, geometry, or calculus.
Oh God, are we gonna do that today?
Do what?
The quadratic equations, algebra, geometry, calculus.
You like these chapters? We'll do it next
No,
time.
I don't. I'm not. Can we not do this now?
We are not. I'm just telling you for what it is used.
Okay.
So
Anyways,
can you give me one quick example where square roots are used in geometry? I'll give you a clue. It's something to do with triangles.
oh, let me think about that.
Quick.
Mm.
No, you cannot Google. Gautam, stop Googling.
All right, fine. I won't Google it.
Your brain is bigger than Google. So where do we use the squares? I see you're still Googling.
Well, I'm not Googling anything.
Yes, you are. It's for a theorem. Okay, another clue.
Wait, the Pythagorean. Oh yeah, Pythagorean theorem, right?
Okay, for that. Okay, so let's take a very simple number for 25. Do you know the repeated subtraction method?
Oh yeah, like for example, like if you're going to find like the square root of 25, I know that it's 5, but I'm just saying, then what, we keep minusing 5 until if it reaches 0, then that means the number you're minusing to that big number is the square root.
No, which number do you use to minus it?
The number that's the square root of it.
No,
Of the
no,
number
no. Okay, you're saying for 25 because you know 25 square root is 5. If it is a very big number, what do you do?
prime factorization, repeating subtraction.
No, let's just
Oh yeah, you estimate.
estimate. No, for the same. Okay, listen, you didn't get my question. Wait. Now we'll start with 25. You know prime factorization, right?
Yeah.
Prime factorize 25.
That's easy.
Okay, you got this, right? Same.
Give me some prime factorizations and I'll do those.
I'm going to give you all. I'm going to teach you first what is subtraction. Repeated subtraction is nothing but you just keep minusing till you get 0. That's what.
Yeah, I know. I already knew. Yeah, I already knew that to begin with.
The number that you subtract with should always.
5.
No, that's where you're wrong. It is a repeated subtraction method. It should always be odd numbers. The first one, the next 3, 5, 7, and so on till you get 0. So 25 minus 1,
24.
24 minus 3,
21.
21 minus 5.
16. Then minus 16, then minus 7 equals 9, and then minus 9 equals 0.
So how do you
calculate numbers? Then there are 5 numbers, so it's 5.
Good job. This is how you do it. So can you please now try it for 81?
Okay.
Same. Okay, you got the answer.
Erase everything.
I have.
All right, I'll just write the next number in the sequence instead of just writing to subtract, okay?
No, can you please write it fully? You know, right? In maths, the answers just don't matter. Everything matters. The steps, how you derive it.
All right, we're at 0 now. So how many numbers did we use? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the square root of 81 is 9.
Good job. You know normal estimation. Do you know how to do it for imperfect?
All right, all right, I'll give you an example. I did not, all right, for example, just given saying I do not know the square root of 11, I want to find out. But I know that the square root of 10 equals 100 though.
Okay.
So then we can, all right, so this is how square root goes. So, all right, it goes to 1 and then you add, all right, and then you keep adding odd numbers.
No. Estimated by, I'm asking estimation you usually use for square roots in decimals, not for perfect squares, only for decimals, because it will make it easy. For 11, etc., you can use the repeated subtraction method or the factorization.
Prime factorization.
Okay. So
but I guess the repeated subtraction is the most useful.
Yes, but prime factorization is also useful. For example, now find out if 1486 is a perfect square. Use prime factorization.
Yeah, but these aren't perfect squares, but whatever. These.
Are you sure they're not?
Yeah. See?
You don't do prime factorization like this. They are not single numbers, right? You guys don't, wait 1 second, I'm just clearing this. You guys don't do this prime factorization this way?
No. I think that's just how they do it in America and India, but that's not how that works in the US. It's
okay. See, for this number, you cannot split this number 14 and 8 into 2. Can you just see if it works out? 14 as 7 into 2 into, what did you put as 86 as?
yeah, so 1 and 6 are left
1
now.
and 6, or is it 106?
Yeah, 106, right?
You still have to prime factor it.
Mm-hmm. That's the prime factorization.
Okay, do you think this is a perfect square then?
Nope.
Okay. Do you think all big numbers? Do you remember the rules?
Yeah, prime factorization.
Wait.
Prime factorization.
I'm just taking the
Repeated subtraction.
Okay, can you prime factorize 576?
Mm-hmm.
Yeah. What is the answer?
This I'm writing it down. There.
I need you to tell me what the answer is.
2 times 2 times 2 times 2 times 2 times 2 times 3 times 3.
You'll be getting a number, right? What is the number?
576.
No. You cannot put 2 times 6. You're just
No, 64 times 9.
That will be 576.
Mm-hmm.
I'm asking the square root. We are finding the square root. We are not prime factorizing. Square root means
Oh, right. Yeah, right. Okay, sorry. Okay, whatever. All right, whatever. It's 24.
it's 24. Are you really sure? How do you get 24?
I don't know. Just did, okay?
You've done it. So here 6 and 2, right? Till this. Got it till this, right? You did it on your own. So you have to take 2 digits. So just split up. Like 2 into 2 into 2. Wait, I'm just clearing this and just put the 2, 6 and 3, 2. Okay. 2 into 6 into 3 square. So you have to have 2 numbers for it to be a perfect square, 2 of the same numbers, right?
Mhm.
So you can write this in 2 ways. One is the exponent form, which will be, what will be the exponent form for 6? Or
Wait.
we'll just give it in the simpler form for you first, then next video.
When is class over?
Another 20 minutes maximum.
No, I want to go so bad.
So 3 into 3. So when you square root it, you get only a single 3. Okay. For 2 power 6, it is like 2 into 2 into 2 into 2.
When will this class be over?
Few more sums, then I give you the rest as homework. Okay. So how many 2s are here?
4.
3 pairs, 6. So you have
Yeah,
6.
right.
So this 8.
24.
Yeah. Okay. Now we go to the last one, which is estimation. Or you want to do some sums as
Yeah,
well.
that's what I don't want to learn estimation. Can we just do sums?
Okay. We'll do around 10 sums now, then you can take the rest as take home. How does that sound?
Okay, fine. All I hope is these sums don't take as long as 15 minutes.
It won't, we'll just give it as homework. Okay. Is it okay?
Okay. Yeah, okay. Let me just go on, please.
Square root of 36.
Wait, what?
Square root of 36.
Did you say pi?
I said square root of 36.
Okay. All right, I'm gonna use repeated. This is small. I'm gonna use repeated subtraction.
If you're sure that it's a perfect square, do it directly. Okay. If you're not sure it's a perfect square below 100, use repeated subtraction or factorization. It's your choice.
I'm just gonna do this. I don't want to use repeated subtraction. I'll just use repeated subtraction because it's a small number.
Seeing 36, can you see if it is a perfect square or not?
Yep, it's a perfect square because it can be subtracted 6 times.
Okay. The fastest thing to do for all these numbers is, it's a perfect square. It comes in the tables. So just write down 6.
Okay, yeah, I just wanted to, okay, who cares? Let's just move on now. Let's move on.
Okay. 144.
12.
289.
Gotta think this out. Oh, yeah, 17. I did the math in my head.
You did the maths in your head. 0,
0.
55.
There is no square root for 55.
I want you to do the repeated subtraction. Okay, wait, this is where the estimation comes in. Okay, wait, we'll just stick on to perfect squares for this class. We'll go to the estimations in a
If we're
minute.
gonna do a continuation, let's just do estimation next time.
Yeah, we'll do estimation next time. Okay, 81. I'm calling
9.
up
9.
196.
16.
16 or 13.
16.
Are you sure?
Actually, wait, let me think.
No, don't Google it.
Okay, yeah, I'm not correct. Okay, yeah, I did the math. I'm not correct.
You can use a pen and paper, you know, instead of searching in Google or
I
in
know.
paper.
Okay, it's all right. I'm stupid. It's 14.
256.
14. Yeah, 256 is 14.
Then what is for 289?
What?
289.
17.
225.
225. 15.
221. 121.
11.
64.
8.
81.
9.
144.
12.
So got it. So next class we'll go in for estimation, and will you be bright and fresh and tell me not?
Yeah. Oh, okay, I'm just fixated on going to that puja, so yeah.
Are you sure? Okay, sit. Let's just do the meditation. Then you can leave, baby.
Mhm.
So which part was hard for you today?
I guess it'd be prime factorization. I got the prime factorization. I didn't know how to do it. Anyways, let's do meditation.
Okay. Inhale, exhale, okay?
Mhm.
Exhale. Inhale. Exhale. Inhale. Exhale. Inhale. Exhale. Bye, baby. Have
Bye.
a good day.
Mhm.